Let's solve a trigonometric equation with inverse trig functions using a sum identity. Friends, this one's got a lot of steps, so I want you to stick with me. We're going to solve the inverse of sine of x minus the inverse cosine of x equals pi over 6. Now, this has a lot going. So the first thing we want to do here is say, well, I'm going to just go ahead and isolate a trig function. And I want things to be positive. So I'm going to add the inverse cosine of x to both sides. So that's going to give me the inverse sine of x equals cosine inverse of x plus pi over 6. Now, to get rid of, right, we want to get rid of the inverse sine because we want x to be by itself. We're going to say, okay, that means x equals the sine of the inverse cosine of x plus pi over 6. And now you hopefully recognize I have the sign of a sum. And so I can rewrite this using our sum identity where we have the sum of a sine function. So I'm going to rewrite. I've got x equals the sine. I'm going to just rewrite this real quick so we know what we're doing. And I'm going to rewrite this out. So I say, okay, I know that x equals the sine of my first one, which is the inverse cosine of x, times the cosine of pi over 6, plus the cosine of the inverse cosine of x, times the sine of pi over 6. Okay, and now we're ready to simplify. The problem is we've got this pesky guy right here. So let's think about what this means. We are in quadrant 1, and I know that because we have pi over 6 over here. Okay, so let's just think about, I'm just going to draw this out on the next page. Okay, in quadrant 1, we know that we have, the inverse cosine of x. That means the cosine of our angle is x over 1. So if my angle is theta, cosine is adjacent over hypotenuse. So if I want to find the other leg of my triangle, I would say, well, hypotenuse squared minus the side squared gives me the other side squared. So 1 minus x squared equals something squared. I square root both sides, and that means my missing side is 1 minus x squared. Okay, the square root of 1 minus x squared. That's going to be important. Because when I go back to my problem and say, okay, I'm ready to simplify, I need the sine of this beautiful piece. Well, the sine of that is the square root of 1 minus x squared over 1. So x equals the square root of 1 minus x squared times the cosine of pi over 6 is radical 3 over 2 plus, now this is the beautiful part, cosine, inverse cosine cancel each other out. I'm just left with x, and the sine of pi over 6 is 1/2. All right, now this is pretty ugly. But, okay, I have this pieces all together because it's multiplied, this pieces all together. I want to eliminate my fractions. I'm just not a fan of fractions, so I'm going to multiply everything by 2. So 2 times x gives me 2x. 2 times this piece, well, the 2's cancel out, and I'm left with radical 3 times the square root of 1 minus x squared. And then in the second piece here, the 2's cancel out, and I'm left with x. Okay, we're making progress here. Let's go ahead and move the x to the other side. So these go away. And I'm left with x equals radical 3 times the square root of 1 minus x squared. All right, I'm multiplying two things together here. Well, this is pretty ugly. So I'm going to go ahead and we're going to square both sides. We got to get rid of these radicals. So if I square both sides, I have x squared equals 3 times 1 minus x squared. Okay, this is not as bad as it could be. Let's go to a new page. Again, I have x squared equals 3 times 1 minus x squared. Okay, great. So let's go ahead and distribute. So x squared equals 3 minus 3x squared. Let's add 3x squared to both sides. So 4x squared equals 3. Well, divide by 4. So x squared is 3/4. Square root both sides. And x equals radical 3 over 2. After all of that, remember, we started with the inverse sine of x minus the inverse cosine of x equals pi over 6. And we end up with, if x is radical 3 over 2, it solves the equation. There's a lot to that. It takes a bit, but if you work step by step and remember what you know, apply your algebraic skills where appropriate, you get your answer.